Welcome to this episode of Artificial Idiots. Jenna, Jack, Randy, and I'm Josh. The whole gang's here. And let's congratulate Jenna on her new gig. She is now a full-time AI nerd. What's your official role and title, Jenna?
Director of Applied AI Media.
Oh, fancy. Director.
Hello, I'm fancy.
Yes, so we've got the brains, we've got the brawn, we've got Jack in the house who has dropped a topic that I think is really interesting, not only to me, not only to investors and small business owners, large business owners, corporate owners, but also you, dear listener. And we're talking about reducing AI hallucinations and increasing AI accuracy. And so this is a really big economic driver. We're finding that many companies are not adopting AI mainly because they're afraid that it's not reliable enough, specifically with the hallucinations. And I just talked to a CEO at a healthcare company just 2 days ago, and he's like, yeah, I know I got to get on that ship. But here's the thing. I don't want to have my employees put things into AI, into Copilot or ChatGPT, and rely on the information that's coming out. Because especially in healthcare, that information is really, really crucial, right? So you want to make sure that that chat bots specifically are usable. Applications, agents, more reliable because it's a closed system to some extent, but chatbots are still, they've got a bad rap. So Jack, what is the study that just came out that makes this somewhat possible? And maybe are there green shoots? Are we looking at a light at the end of the tunnel? And is AI going to be more accurate going forward?
I think that's a sort of multi-part question. Let's sort of take it from the top. So I came up with this topic because I was doing some research. Just my feed gives me a lot of AI content, and it gave me this paper published by OpenAI on September 4th, 2025, which as of the time of this recording is just 5 days ago. And it's called Why Language Models Hallucinate. People have been putting out theories, all of which have kind of contributed in some way to this paper published by OpenAI alongside a Georgia Tech student. And it goes through a variety of reasons why, and it has to do with an acronym RLVR. Is anybody familiar with that? If not, I can break that down. It's called Reinforced Learning with Verifiable Rewards. And at a very, very basic level, what this means is that when you train a model, like, for example, how OpenAI, Claude, potentially Grok, have all trained their models such that it is reinforced with a verifiable reward, basically saying, I output this thing, it looks right, I'm maximizing the ability with each response that I give to anybody putting in a prompt that this is going to be the most, or the thing that you want to receive back most from what I've put in as a prompt. Rather than saying something like, for example, I don't know. And they actually have a really good graph in there to sort of illustrate this. For example, I don't know if anybody has also seen this sort of going around the internet. There was sort of a trend happening, for example, where it was like, how many R's are in the word strawberry? And people would be asking that to whatever frontier model that they prefer. And a lot of the times it was getting it wrong. And so people were kind of wondering, why is that? And we now actually have a pretty good idea of why that is. So all of these large frontier models are trained on pattern recognition. They're all matrix multipliers. They go through and try to determine, based on whatever the previous pattern is, what is most likely to emerge directly after that. And it builds it sort of cohesively, generatively, right? So, for example, if you were to ask an AI, hi, how are you? It would say, oh, how can I help? Because that is a pretty likely response that it would see in its training data, for example. However, something like counting may be a bit trickier because it would have to see a lot of data where people are counting letters, for example. And it actually goes and gives you a really insane version where it's asking, hey, what's my birthday? It'll just throw out any date because it knows to answer with a date and a time, but it has no way of knowing what your particular birthday is. So there have even been countless examples, even in studies, for example, where the training data that you give it matters. There was a study done, I forget by which university, but it was trying to find, I believe, malignant or potentially cancerous moles on people's body. And it was trained with a variety of photographs, some that were later found to be cancerous, some not. And what it actually found is that rulers are cancerous because a lot of the photos of cancerous moles had rulers in to be able to see how large they were, right? So your training data matters. And so one of the reasons why this can happen is based off of how these models were trained, which is reinforced learning with verifiable rewards. Basically saying, if you get this right, you get a boost in your score, you get a little reward. It means that you're getting things right. And it can lead to some of these biases in these larger models. And that's sort of what this paper is now summarizing and saying that this is why hallucinations are happening. Sorry, I know that's a lot.
Yeah, it's a really dense topic. I mean, I've always wondered, what is behind the hallucination? Why is that? I knew it had something to do with the training model, but this has kind of been behind the veil for a long time. And so I'm glad that we're now being able to lift that veil, get a peek behind the curtain, and see what's going on under the hood. That's like 3 metaphors in under 20 seconds, a new world record. Randy, when you hear all this stuff from Jack, what does it make you optimistic now that you have like a new lens through which to observe this problem? And do you think that it's something that is truly solvable now that you have a better understanding?
Yeah. I mean, yeah, there's some studies out there that say like hallucinating is more of like a feature than like a bug or whatever. But, those are definitely fascinating. I had a bit of a light bulb moment just from a security perspective where, you have two different, just from a developing perspective, you have two different types of models to build your business off of. There's like what they call it, like the commercial models, which there's hundreds. There's like 400 or 500 you can choose from. And then there's like the open source models. And like, how do you know how these models were trained? And the commercial models, they're closed. They don't really tell you how. So to answer the question, like, will commercial models continue to hallucinate? I don't know. You can't really rip those open and look under the hood and see what's under there. But the open source ones you can. So that's interesting. But then in terms of, will we see next gen models that basically don't hallucinate? That's probably a thing. Mm-hmm. I think I'm starting to see it now. Like, yeah, with like GPT-5 and software development.
Is there a third-party solution for this? So is there something that you can do to if you're using ChatGPT or Claude or one of those, large language models, is there something that you can plug in? You remember that episode that we, when we talked about plugging something in a JSON string that allows you to sort of sidestep the barriers? Is there like a workaround or a prompt that we can use that would increase the accuracy of the outputs? So like what we would do is like, we would create like multiple agents that are kind of in that same, multiple agents that are trying to look at that same question or whatever. And then you'd basically have like a critic agent. And so if you get some type of weird hallucination on the first guess, the critic agent would be like, hey, wait a minute, like based on the question, based on what you said and kind of, what I'm thinking, it's completely opposite. Hold on. And before I give it to the end user,
let's think about this a little bit more. And then eventually they come to some conclusion. And usually when you have that like agentic workflow or whatever, the accuracy goes up a little bit, but it's not like what this paper and what Jack revealed on this research. This research is like has the potential to be revolutionary with the next gen.
I think that Randy raises a really, really good point, in that the current way in which agentic architecture is being built right now, and is effectively what GPT-5 included, is not necessarily to say a Band-Aid fix, but it's an after-the-fact fix. All of the training has already been put into this frontier model. It's already trained. It knows what it's doing. Obviously, user inference, and it can continue to be trained, but it's being trained in such a way with this RLVR, such that a lot of the steps you have to take are sort of after the model has already been calibrated. And Randy raises a great point in that this sort of, whether or not you want to call it a evaluator agent, a critic agent, there are many agentic workflows which are doing this, reevaluating, respinning up agents to try to find some sort of answer that's closer to the net truth based off of a sort of cycle of, for lack of a better word, thinking or reevaluating, right? What this would do is start you from a higher foundational accuracy, such that when you then go into that agentic workflow, you're starting from a place closer to the original,
next level,
closer to the real truth, right?
So for the average user, Jack, what would they need to do in order to get this up and running in their current workflow?
So I think that answer has sort of two parts to it, honestly. The first part is an acknowledgement of, unless you're building a frontier model like a ChatGPT, like an like a Claude, for example, yourself, there's not a one-to-one way you can replicate this, right? These frontier models are so large and ubiquitous because they've already done all of the training for you, right? In the same way that there's this so-called rush to AGI, I think that what you're going to end up seeing is a lot of frontier models rushing to implement this new solution that we can talk about in a minute. In the shorthand, for a end user to get sort of a taste of what this may look like, a lot of what you would want to do is, let's say you are in a chatbot or a prompt, you should always try to incentivize whatever window you're in to tell you if it is unable to answer your question with above a 90% certainty. That is the sort of Band-Aid hack fix that average everyday users can implement today. And if for whatever reason it can't give an answer with above that level of certainty, then you should have it try to work it out and reason with you, human in the loop.
Mm-hmm. So Jenna, it doesn't seem like it's going to be coming down the pike anytime soon for you. I mean, it's in the works, but it's probably not going to hit your workflow anytime soon. But how do you deal with hallucinations today? Because as a power user, as an above average user of AI, I'm sure that you understand it, well enough and can work around it well enough in order to deal with those hallucinations. Because you're not putting up with like false answers every day and having to ultra validate every single response, are you?
No, and I do something similar to what Randy does, but just instead of it being multi-agent, it's just me and multiple models. And so I'll use Gemini as well as ChatGPT. And it depends on if it's a high stakes, if this is like, okay, I really need this to be accurate, it's not kind of general learning, then I'll just feed it to the other and ask it to verify it. And just shows, all right, and then it will. And is that perfect? No, but it definitely catches things where it would matter. And it just is a safeguard. But agreed that it would be much preferred for just the actual model itself to start from a place of more accuracy, which soon cometh, it seems.
Yeah. Now, I was talking to a healthcare CEO the other day, and he is just like, smart guy, really on board with it, but he's like, I don't want to put this into the hands of my employees because they have to validate everything. That's the huge problem. And it is a legitimate problem when you really think about it, because it's not just 20% hallucinations or 30% or even 1% hallucinations. It's if you know that there are any hallucinations, you need the humans to go back and validate everything. So your answer is to be multimodal, right? If you're multimodal, are you comfortable relative to human beings? Are you comfortable trusting, just taking what your models are validating and the outputs that they say? Claude says ChatGPT is as bullshit. ChatGPT says Claude's on bullshit. Okay, do you trust them enough to be able to live with it, I guess?
Yeah, I mean, there's different layers to it. It's if this is the thing I'm going to say to a top client, then okay, if there's any worry there, I also check the sources myself. Like there's a hierarchy of what's going to be verified. But to the CEO's point, there's also, it just depends on the work too, because there's situations where you're just going to have a higher possibility for hallucinations versus others. And so I think sometimes when people hear this rate of hallucinations, they think that it goes for everything, and that's not true. So if it's something like correct, like true, false, something that's very clear cut, it's a lot better at it. But if it's going to be a situation where there's all of this different context and it's weaving together, that's where hallucinations can be a bit more rampant, I found.
Could you give us a couple of examples, like what you wouldn't use it for, or where you would need additional validation?
So where I would need it for additional validation is if I was, okay, I'm researching something and I'm giving a lot of context about my client and what I'm needing. And then additionally, I'm going to layer deep research on top of that. It's a lot to work with. And that's where some stories can start getting weaved, or some facts that look beautiful. I would love to use that fact in my deck, but it's not real. And so it's situations like that where I'm like, oh, I really love that stat. Gonna check that one. However, if it's, look at this spreadsheet, let's grade the sentiment, or is the sentiment positive, negative? Those have been spot on.
I trusted to train my new hire. I have a new hire, and so he accesses our code base, it's like a private code base up on GitHub. And he uses basically, it was easier for him to talk to AI to ask questions that he had about our code base than it was for me to teach him. And it explained it to him in his way, because he's got a different knowledge set than I do, and so he just had different questions of the code base. And the dude started Monday, and he's got a minimal viable product where he took over an entire SaaS app for this cybersecurity company. He did 2 months worth of work in 5 days or something, with almost no discussion from me. He's just chatting with the code base. Seriously. I fucking
put these two scenarios into we have two different buckets here. You guys correct me if I'm wrong. One, you've got feeding AI something that's already known. So a code base or an email or a spreadsheet or some data repository, some information repository, and asking it to recall information from that and analyze it. So that's one bucket. And then the other bucket is you're asking it to go into its own training data or into the internet and recall information. So would that be the two main buckets where, on one side, you're feeding it the information. On the other side, it has to go out and find the information. And if it has to find the information, it's less reliable. And if it's feeding on existing information, is it more reliable? Or
I think that you're thinking about this potentially in, all right, how do I use this AI model? We're talking about training an AI model before it ever hits the market, right? To my knowledge, none of these frontier models have been trained in this new way, such that when they release their marquee product, that it has this level of accuracy. This is sort of a company-wide improvement that would have to be done by the engineers at each of these frontier AI solutions. So to answer your question at the top of the episode of when will we see this in OpenAI or in Claude, we won't know. And likely they will probably be in a race to develop the first model that uses RLCR to train their frontier model rather than RLVR.
Reinforcement learning happens at the very end.
Yes.
Yes.
Yeah, it happens. Yeah, it happens at the end, like Jonah said. Yeah.
So
Okay. Yeah, my scenario is more like the existing models, like a workaround for the existing models.
Yeah, like whereas hallucinations more likely. I think it's more about having the type of ask for it as well as the information. So if it's like, here's the information, true, false, that's going to be good. Summarization, good. But if it's like, here's the information, no matter if it's taking it from your spreadsheet or also the internet, as well as, and you're just layering on additional context and additional context that's having to weave all this together, that's when you're getting into hallucination ripe stage.
Okay,
Right.
just to clarify, because I think we had a little bit of dissonance here. Just to clarify, you've got the existing models, and how do we reduce the hallucinations in those models? And there are a couple ways to do it. For you, Jenna, it's all about layering and the questions that you're asking it, how you put the information that you're putting into it, and where it's grabbing that information from. That is another, factor. And then you've got this other thing, which is what the entire main topic here is today, which is the original, the OGs of AI, and the original code base is what I'll call it, because I'm a moron. I don't know what else to call it. So the original training data, and now there's a race to adopt a new technique that's going to reduce the hallucinations at the ground level so that we don't have to have these workarounds. And that's not out yet.
correct.
No,
yes.
but what like Jack said, or they're like doing it like right now, probably. They're like cooking it right now. So I'd say like fall.
So ultimately, here's sort of the difference between these two approaches. The first is RLVR. That's what all of these frontier models, as of now, are using to train their data. Basically saying, are you able to provide a good response immediately, yes or no? A lot of times, even in like ChatGPT messages, it'll ask you to thumbs up or thumbs down every single response, right? And a lot of the times, if you can't define a clear reward or punishment for a given answer, it's not factored back into the model to make it more accurate, right? Where this new paper proposed by MIT comes in is they are pitching a new method of enforcement learning called RLCR, which is reinforcement learning with calibration rewards. This enables reasoning models. Here, this is actually a direct quote from this paper. RLCR enables reasoning models to improve both accuracy and calibration. Our approach trains models to reason about and verbalize uncertainty, preserving task performance while significantly improving calibration in and out of distribution. Very basically, this means that responses such as, I don't know, let me try to get close, or let me ask you for more information will also be factored in as a reward towards a better model.
Because currently the reward for I don't know is virtually nothing.
Yes, exactly. And a main reason for this, and this is more speculative, but in order to retain time spent on these platforms, these companies are making their AI more friendly and trying to give you the answer that they think you want, whether it's right or not. Whereas what this new way of calibrating data would do is prioritize facts and accuracy rather than what a model thinks you want to receive as an answer.
Reminds me of like a 5-year-old when you're like, what's 2 plus 2? You're like 7. Like, no, what's 2? If I have 2 apples and I take and I put 2 more apples next to it, how many apples do I have? 8? No, they're gonna tell you what they're just gonna throw spaghetti at the wall and see what sticks. Yeah, because they might, especially if the reward. Yeah, the reward might be like a candy bar, so it's worth just throwing something out there, and maybe they'll be right.
Actually, it's not as strategic just to shoot your shot. It's more strategic to say you don't know because you get partial points for that. And because if you say if you do shoot your shot and you're wrong, then you get 0. So it's
that's what my teacher always told me, and she was a liar. She would say, "I don't care if you don't know the answer; just say you don't know." Well, I don't know. And then I got punished for not knowing.
That is not reinforcement learning with calibration rewards.
That's a Caribbean teacher with a ruler.
Yeah, that's
every time
that's like
you get smacked.
That's like some real behavioral modification, you know?
Yeah. No wonder I turned out this way. I'm all wonky.
Exactly. I actually really love that analogy. Rather than having a teacher that would punish you for not knowing the answer or would ignore you, what RLCR would be a teacher saying, okay, you don't know. Let's figure out what you do know, and let's go from there. Okay, you don't know what 2 plus 2 is, but you know what 1 plus 1 is, and that's 2, right? So what if you had another one of those? And it's working like that in a collaborative way to get to what the actual answer is, rather than you or that teacher just saying, all right, yeah, sure, it's 8, whatever, like, and moving on about their day.
Question about the thumbs up, thumbs down. Does that really work? Because I don't use that thumbs up, thumbs down. I don't know anybody who always uses the thumbs up, thumbs down. Do you all always use your thumbs up, thumbs down? And how much does it contribute to the model, really?
I do. I do just for testing. I mean, it does work. Like, you know, I have like a thumbs down button in TCA, and you could be like, I hate it when you give me clear text responses. Always respond like, with red or something. And then it'll just always respond in red or something. But like, there's like no logical purpose for that. Obviously, that's just like a test case. But I mean, it's supposed to adjust the model so that future responses maybe take that into account. And I've seen it. I've seen it behave that way.
Okay, when the new model comes out, are we going to have a thumbs up, thumbs down, but it will be just out of the gate, it will say that it doesn't know more often?
Yeah.
Or how do we interact with something that is open about not knowing? How do we reward it? So when it says, I don't know, do we give it a thumbs up? And how does it know that that's different from getting the right answer?
And I don't know if those thumbs up directly train the model, or if it's more inputs for the engine to like inform training the next time.
It is that, Jenna. You would be correct about that.
Really?
Yes. Yeah. So a lot of the times what will actually happen, and for the record, I have no suicidal thoughts. Do not come for me. Okay.
Where's this going?
A lot of these frontier models, what they will do is when you give a, thumbs up or thumbs down, they will have a sort of real life training center with human people who are paid very, very low wages in other countries. Let's put it that way. Whose whole entire job is to go through and say, all right, why was this a good response? Why was this a bad response? Effectively, human evaluators, like that evaluator agent Randy is talking about, who then, that's what their labor is for, is to do that so that they have more data to retrain the next model.
Dude, that sounds so dismal. I feel like that's like so dark. So
yeah, it's unfortunate. Yes, it is quite a sad practice, truly. But unfortunately, the technology is not going anywhere. What I would argue is that these people should be paid much higher and livable wages. We'll see if that happens. Hopefully it will. But hopefully
So how
this will
right-
be able to offset that.
How right do they have to be all the time? And when
That's
they
a
say,
great question.
because they're doing the validation.
Right.
Requires a lot of critical thinking and education.
Yes.
Right.
That could be a part of it. I think it may be interesting to even, I don't know if anybody would be willing to do this research, but to sort of follow the money, see where each of these training centers are that each of these individual frontier models are using, and see what the, I believe there's some sort of like countrywide education index that you can see like which country is ranked like most intelligent, K through 12, what have you, and potentially even comparing where those training centers are. That might be a interesting study for someone interested in doing that research.
I think you might want to pay those people more money.
I would agree. Yeah.
So here's the conundrum. It's going to be really hard to convince people who are already convinced that hallucinations are always going to be a thing. Because again, if it's even 1%, they're going to say that we need to validate it. So they've just written it off. For those people who have written it off, let's assume that there's hope for them. What would you say to them that would bring them back into the fold and convince them that AI is not worth giving up on?
I would be curious and ask them for more information on what use cases they would have AI help with and the problems to have solved, and just give them education. Because if you're opening up those use cases and we're kind of in that zone of what we talked about before where AI is really strong and hallucinations are really rare, then we could even pull up some tests and some evaluations. It's like, okay, well, let's score good or bad, and we can really show them, okay, this was correct. 100% of the time, if it's in a zone that it's really good at. I think it's just experimenting with it, and also just making sure that you're not setting yourself up for failure. Because if you're also going to be saying, all right, you're going to be using it in these really high context, complex situations, then you probably shouldn't. Or you should be able to build in safeguards for that and make sure that your people are really trained to verify that information. So I think just education and making it real for folks.
Would it be a bad idea to have like a validator, like a chief validating officer? Or
I think that's going to be a part of everyone's role. Everyone is chief validator, because it's not something that should live somewhere else. It should be baked into your skill set to be able to be discerning, but also collaborative with the AI.
Well said. Jack,
Thanks.
Randy, anything to add?
Yeah,
No?
I would just say, based on your question, which is, how would you convince these people that, you know, any length of risk is too much? Here's what I would say to that. I would say that this new way of training, RLCR, is more human-centric, it is more accurate, and it is more fact-centric. And what I would say is when using AI and discussing accuracy, period, what I would do is exactly kind of what Jenna is saying. I would audit whatever the use case is, see whatever the current accuracy is, and then simply compare and contrast whether or not this current model of AI would be accurate or better than a human in terms of accuracy. Measure, all right, this person's accuracy in terms of whatever this task is only 78%. This current model is 65. It's not better. Or it's 82. It is better. I think what we will see is people who are having those conversations, once this new model comes out, the margin of how much more accurate the AI is will boost significantly.
Well, we'll just have to wait and see. And perhaps the new Apple Siri, Apple Intelligence would have something like that in it, because God knows Siri needs it. God, Siri's so dumb. I'm sorry.
I know.
I didn't say that. She can hear me.
No, it's cool. It's
That was
they
me.
deserve that.
Oh my
It's earned.
gosh.
They've
They
earned
just
that.
please,
Yeah.
for the love of all things Apple, Fix it. All right. Thank you for listening to this episode of Artificial Idiots. Check out Compliance Aid. Go to thecomplianceaid.com. Randy really put everything that we've been talking about and everything that we've learned about AI in the past, 5 years into the Compliance Aid. And it is a walking, talking testament to AI and really what this field is all about. And I 100% endorse it. And anybody who's into the compliance space, cybersecurity, GRC, check it out. You might not find it useful, but you just might. So, thecomplianceaid.com. And if you want to learn more about us, check us out on LinkedIn. We're all in LinkedIn. Jenna Gardner, Jack Carden, Randy Blasik, Josh Bruning. And if you want to learn more about Bruning Media and what we do, check out bruning.com, BRUYNING.com. Thanks for listening to this episode of Artificial Idiots. Bye.